next thing we need to talk about is standard scores and computing standard scores. So what is a standard score? The number of standard deviations a data value lies above or below the mean is called its standard score or Z-score. And in order to do this, we take our data value minus our mean over our standard deviation, and this will tell me how far any value is, how many standard deviations a data value is away from the mean. They can be positive if the data value is above the mean, and they'll be negative if our data value is below the mean. So an IQ test is scaled so that its scores have a mean of 100 and a standard deviation of 15. So let's find the Z-score, so the number of standard deviations. These data values of 85, 100, and 125 are above or below the mean. So Z equals X minus mu over standard deviation. So the Z-score for 85 would be 85 minus 100 over 15. That gives me negative 15 over positive 15, so I have negative 1. This value on the normal distribution would fall below the mean. Next, if I have a Z equals 100 minus 100, because 100 is the mean itself, of course it's going to be 0 standard deviations away from the mean, right? 0 divided by 15 is 0, right? If I'm home, I'm 0 miles from home. So this makes sense. Next, I have to take 125 minus 100 over 15, and I'm going to get positive 1.67. So this would fall above the mean. So we have one value that would fall below the mean, another that falls on the mean, because it is the mean, and another value that falls above the mean. Now, one thing that's really cool is once I know the Z-score of a data value, the properties of the normal distribution allow us to find its percentile in the distribution. And we're going to do this using a ZScore table. I have posted one on Canvas, and there's also in your book, and you could probably Google and find a PDF of one, but I like the one I posted. So we're going to learn how to use a Z table, and we're going to interpret the Z scores of -1, 0, and 1.67, and find the percentiles that relate to these specific scores, Z scores. So my first Z score was 85, right? Let's go ahead and draw a nice little normal distribution. Oh, I can't draw up there. Okay, so here's my normal distribution. Let's try that again. I had 100, 85, and 125. And I want to figure out what percentiles these marks. Well, 85 had a Z score of 1. So I'm going to, of -1. So I'm going to go to -1. This is my Z score. And it was just -1.0. So I find 0.1587. So that means the area below 85 is 0.1587. And that makes sense, right? 85 was on the first standard deviation, and the amount of data values below the first standard deviation is 16%. So we're really, really close. Next, I have 100. It had a Z-score of 0. And that makes sense, right? We've got 0.50, 0.50 for the 0. The mean divides the distribution in half. It makes sense that it marks the 50th percentile. Next, I go to 125. This had a Z-score of 1.67. So I go to Z, I go to 1.6, and then I go all the way across to 1.67. I went too far. So I have that 125 has a Z, the area below 125 is 0.9525, so it marks like the 96th percentile. Here we've got the 50th percentile, so that means 50% of values are below it, and 85 marks the 16th percentile. That means that 16% of data values are below it. So we should probably do a few more examples with these to feel really confident in calculating Z scores and using a Z table. So cholesterol levels in men 18 to 24 years are normally distributed with a mean of 178 and a standard deviation of 41. What is the percentile for a 20-year-old man with a cholesterol level of 192? So first things first, I need to calculate my z-score. I take my data value minus my mean over my standard deviation, and I'm going to get 0.29. That's my z-score. This is not our percentile. So I take my z-score to the z-table. I go to 0.2. I go all the way over to 9, and I see 0.6141. So that means if we want to round up, the men with a cholesterol level of 190 mark the 62nd percentile. Very exciting. Next, what cholesterol level corresponds to the 90th percentile? The level of treatment that may be necessary. This means I need to go into my z-table and I need to find the z-score that corresponds to a z-table value of 0.90. So why don't we do that? Okay, where does 0.90 on my z-table? Here we've got something kind of close. Keep going. Here I've got something really close to 0.90, and that is 1.28. So my z-score is 1.28. So I'm going to take 1.28 equals some mysterious data value minus 178 over 41, and I'm going to solve for x. I'm going to do that by taking 1.28 times 41 and adding 178. That means I have an x value of 230.48. So I'd go ahead and round that up. X equals 231. So the cholesterol level of 231 corresponds to the 90th percentile, the level at which treatment becomes necessary. Now, what's the percentage of men in this age range that have a cholesterol level of 188 or higher? So remember the z-table, when you find a z-score as data value, you're finding the percentile below. Next, I want to find the area of what's up here. So we're going to do something a little bit different, and I'm going to show you. So we're going to go ahead and first calculate our z-score. Z equals 188 minus 178 over 41. That gives me 0.24. So I go to my z-table. I have 0.24. That gives me 0.5948. So here I have the areas here is 0.594. That was a firework. I'm sitting on my porch. Sorry, everybody. 0.5948. Let's go ahead and round that to 0.60. So I want to find the area over here. I know the area in my total normal curve is 1. So I'm going to take 1 minus 0.60, and that equals 0.40. So the percentage of men in this age range that have a cholesterol level of 188 or higher is 0.40, so 40%. Next example. What is the percentage of men in this age range that have a cholesterol level between 188 and 192? So here I have 188. I know the area below 188 is 0.60. Here I have 192, and I'm trying to find the area in this little sliver right here. Well, I can do that by finding the area below 192 and subtracting 0.60 from it. That'll leave me with just this little bar right here. The first thing I need to do is calculate the z-score. So I've got z equals 192 minus 178 over 41. That equals 0.34. I'm going to go to my z-table, and I find that a z-score of 0.34 has a z-table value of 0.6331. So let's just say the area below this is 0.6331. That's all of this. So I'm going to take 0.63, let's round it, minus 0.60, And I find that 0.03 is the area of this little sliver right here. That means that 3% of men have a cholesterol level between 18 and 190. Sorry, between 188 and 192.